All right, question 5 here on the AP Stats practice test. As much as I complained about question 4 and how I hate it, I kind of like question 5. I think this is a good question. Oh, maybe you don't care. What's going on in this problem is we got a histogram displaying the frequency of waiting times for 175 patients in a dentist's office. And what we're being asked is which of the following could be the median of the waiting time in minutes. Importantly, they throw this could be in here because it turns out there's not enough information to figure out the exact median of the waiting times. So how do you answer this question? Well, you need to know what the median is. You might think about the median as the middle observation. Maybe parenthetically, I'll add in an ordered list. All right, so if you had, 9 data points, maybe you had a 30 and a 20 and a 5 and a 10 and a 12 and an 11, 2 2s and a 25, sure. You got 9 data points. What you do if you want to figure out the median, or one way, is you first order your list. So from least to greatest, I got 2, 2, 5, 10, 11, 12, 20, 25, 30. And then all I got to do to figure out the median is select the one of these that's in the middle. It looks like this 11 is in the middle. And you're like, yeah, that works out great as long as you have 9 observations. But what if you had 175 observations? Would you really have to look at it and guess where the middle is? No. As you likely know, the middle observation is the n+1/2 observation. So in this case, since I have 9 data points, n is equal to 9. 9 plus 1 divided by 2 is equal to 5. I want the 5th observation in this ordered list. 1, 2, 3, 4, 5. If instead of having an odd number of data points, if you had an even number of data points, so if I add one more here at the end, now n+1/2 is not an integer, it's 5.5. All you got to do in that case is recognize that 5.5 is halfway between 5 and 6. So you take the 5th and 6th observations and you figure out the average of those two. So in this case, it'd be 11.5. There's a quick little recap on figuring out the median. So how does that help us in this specific problem? Well, in this specific problem, we got 175 patients, so n is equal to 175. Therefore, n+1 divided by 2 is 176 divided by 2, which is 88, I think. So what I want for the median is the 88th observation in an ordered list. I won't be able to tell you exactly what that observation is, but I should at least be able to tell you what bucket of my histogram that's in. Because look, in this first bin from 0 to 5, I have 80 observations. The 80 smallest observations are somewhere between 0 and 5. The next 50 or so observations are between 5 and 10. So the 88th observation would be one of these 50 in this bin, right? The 81st is in this bin, the 82nd, 83rd, 84th, 85th, and so on, all the way up to the 130th observation in an ordered list. Maybe because 88 is strictly greater than 80, and less than or equal to 80 plus 50 or 130, the median observation falls in this bin. So you're like, oh, okay, it's some number between 5 and 10. The only number between 5 and 10 is 7.25. The answer is B, and I'm done. Yes, however, be a tiny bit careful here. This bin isn't really all the observations from 5 to 10. It's the observations that are greater than or equal to 5, but strictly less than 10. So I don't think they do this to you, but if A was 2.5 and B was 5 and C was 10 and D was 15 and E was 17.5, you might think it's a trick question and the answer can be either B or C, but that's not the case. The answer could only be B. 5 falls in this bin, 10 does not fall in this bin. However, that does not happen in this case. They make it a little bit easier for you. The correct answer is B.